I'm Shashi Kiran with Appcito, and I have here with me Dinesh Subhraveti. Dinesh is the CTO for AppOrbit, and he's also an authority on containers. AppOrbit is in a stealth mode, so we're not going to talk a lot about that, but we will talk about containers. So Dinesh, welcome.
Thanks.
He's also an author of this book called Containers Beyond the Hype. And in fact, the whole topic of containerization came about as a result of his PhD dissertation almost 15 years ago. So let me just toss the ball back into you, Dinesh. You've seen the hype cycle pick up around containerization today, and it had a lot of genesis in the work that you did. So how have you seen this industry evolve, and what's the role you're playing in it today?
So a lot of hype's happening now, but the notion itself has been around for a long time. I was looking for a PhD topic, and I was fascinated with virtualization. And basically, the thinking was that virtualization is really helpful for application management. If applications are what you're managing, you need to expose an interface that applications can directly consume. So there is a fundamental misalignment between what hypervisors expose and what applications expect. And that's the gap that containers really bridge. So with that thinking, I introduced this notion of OS level virtualization. I did the first implementation of Linux containers, and that work was published in 2002 at OSDA conference. That showed for the first time, almost against conventional wisdom, that real enterprise applications can be virtualized, live migrated many years before vMotion and some of these other technologies. And basically, we licensed this technology to HP Labs. I spent a couple of years at HP extending containers to support distributed applications. A company called Meiosis was repurposed around my work, which we sold to IBM in 2005. Initial years at IBM, I spent integrating that technology into IBM's AX operating system. I continued to do this work on containers. Basically, I did checkpoint restart, live migration, record replay of containers, record replay across architectures and operating systems. So my more recent interest is in basically applying containers to different application ecosystems where there's a significant value to be extracted using containers.
That's wonderful. So back in 2002, server virtualization was just about picking up as well. It took a while for it to go mainstream. Where are we in the journey when you put that in context of containers, and what are some of the top use cases that you see bubbling up?
So we're very early. I mean, it is interesting. This has been around for a long time, but what you're seeing in the industry right now is just a superficial thin layer, which kind of can be compared to where virtualization was back in 2001, 2002, right? There's many interesting use cases that are emerging. I talk about some of that in this book. Basically, containers define applications. I mean, that is kind of how fundamental it is. We've been talking about applications as an industry for a long time, but if you kind of look at it closely, this whole notion of application, such a common word, but it doesn't have a formal definition. I mean, software itself is well defined, right? I mean, software has a rigorous formal definition. It's a Turing machine. But application is kind of a fabrication that kind of crept along the way. Sometime between software was introduced and in this modern complex applications. And containers, what they do is they actually lend definition to this notion of application. The way they do that is application interfaces are well defined typically. And in fact, as an industry, we're obsessed with the interfaces. Exactly what interface an application is supposed to expose to the external world is well defined, but what I call an intraface, the interface between the application and the underlying platform itself is hardly well defined. And containers, what they do is they basically put a boundary around exactly what an application means. They decouple the application from the underlying platform, make it into a nice little composable Lego block. Now that makes these applications portable. So that's kind of what is happening.
Helps.
Yeah, and as a result of this abstraction, there's many use cases that are possible. The key one that we see a lot is this medium of abstraction is used as a predictable conduit for delivering applications from development team to ops team. So when you package it in that composable Lego unit, it is guaranteed to work in a predictable way. So that's one major use case you see. And then there's also a couple others. Microservices is one, and basically microservices itself is not a new thing.
Right.
Service-oriented architecture has been there for many years. It kind of didn't work. It failed because service-oriented architecture or microservices basically it's a thought. It's an idea, but you need a technology that actually can deliver that idea, and that's kind of what containers is. So that's another major application of containers. And I also talk about this data center operating system. So they're basically applications themselves are evolving from these single node monolithic entities to client server, 3-tier microservices. So there's this progression that is happening, and the amount of data they need to process is also increasing. So these applications cannot just fit on one node anymore. They're necessarily distributed. And when you have your applications distributed, you also need an OS layer underneath these applications. And this OS layer needs to be able to manage these massive amounts of distributed resources. So there is this layer that is emerging, data center operating system. Right? And for that construct, containers are becoming the fundamental building blocks of that, kind of like what threads or processes are for a single node OS. For a distributed data center OS, containers are becoming that fundamental building block.
So in some ways, if you're looking at the vision of the data center as a pool of infrastructure resources, going down this path is an elegant way of making that happen. That's been
Absolutely.
a bit of a utopia for a lot of people for a while right now.
Exactly. So containers are enabling a lot of these kinds of things, basically DevOps, DevOps, and then microservices and data center operating system, and also even just a better version of virtual machines, like
Sure.
green VMs, right? And these are lightweight, consume very little resources, come up in tens of milliseconds. So that's another major use case and benefit.
So what are some of the challenges that you're seeing for people to embrace, adopt containers, or even microservices? The two are sort of interlinked in the way that they're progressing today.
Absolutely. This is all mostly kind of as a technology. It has been there, and you need to make this into a shrink-wrap product for applications which matter. Enterprise applications, right? There's a lot of work being done for these greenfield modern applications, but you really need to also see how all of these newer models that containers enable can be applied to these legacy applications, and they're important. I mean, they're all over. Right? I mean, the world currently runs on these legacy applications. To bridge that gap is important. I mean, you need to absolutely do that, and part of my interest now is to exactly do that. How do you make legacy applications also work with containers? And to that extent, I mean, we've talked to hundreds of customers and basically try to do this diligence on what exactly matters. I mean, we're not technology limited. I mean, we know how these things work, but basically identifying the right use case and also the right immediate pain point. That's kind of what we've been focusing on, and I think to your question, there are important challenges to be met, important gaps to be closed. With respect to storage, networking, security. I mean, these three can come up a lot. And there's also other, orchestration, there's scheduling. These things need to be done as well. So those are the main things that my interest is.
So if you fast forward as somebody who's been in this field neck deep for a while right now, let's say you fast forward it for about 5 years from now, where do you see this being in the maturity cycle, especially for bringing and mainstreaming these traditional applications and making them containerized?
I think the legacy applications will stay, and I mean, I get this question a lot. Will VMs go away and all of that, right? So there is absolutely no technology goes away.
Yeah.
And there are specific use cases
we
for
still
which
have mainframes running.
there you go. There are use cases for which containers are really well suited, and there are use cases for which VMs are needed. I mean, if you want to run a Windows application and a Linux application on the same piece of hardware, you cannot do that with containers at all. I mean, if that's your use case, containers won't work for you. But there are some use cases for which VMs are not suited. I have a chapter talking about that. Especially in the distributed application world, these instances of the distributed application come up quickly, and they're dispensable in this whole model. Containers are really the right construct, right abstraction. I think that will happen inevitably, and that's kind of happening already. And VMs will play their role, and there's interesting models. Would you run containers on top of VMs? And there's also this thinking about running VMs on top of containers.
So a lot of endless possibilities, a lot of excitement. Clearly, this is a journey that many people are keen to undertake. There's a huge amount of interest that I see, especially around this topic. And so, I'd really like to thank you for joining us here, first of all. And secondly, for those who are watching, if they want to order this book, where do they get it?
So basically what this book, what my effort in writing this book is that I see a lot of media rhetoric about what containers are, and I see all these blogs.
Right.
I was reading a book about containers, and the particular section was about portability of containers. Containers are portable. The explanation is that containers are portable because you can run containers on all kinds of clouds and VMs, but that's not an explanation for why containers are portable. So there is a fundamental sound conceptual structure that underlies this technology. It's the same as any other major technology. If you think about databases, right? There's a lot of actual theory that goes behind it. There is referential integrity, relational model. All of that is there. If you understand the theory behind this technology, you'd be able to apply it more effectively. Same like software too.
Sure.
So you may not need to understand every bit of it, but if you do, it kind of makes you more effective in applying the technology. So basically, I kind of talk about that underlying first principles from which containers came, the resource anomalies and namespaces, and exactly what are the specific theoretical properties of those namespaces that guarantee this portability, and why are container images immutable? Some of these things, right? So it's the missing theory.
Got it.
For the containers.
Audible on Amazon?
It's on Amazon. It's on Barnes & Noble too.
Excellent. So Dinesh, thanks again for joining. And that was Dinesh Subhraveti, CTO of AppOrbit and author of Containers Beyond the Hype. Thanks again.